Good morning. The goal of this video is, first of all, to get through the video without coughing, and so you have a complete video for class today. And the second goal is to have you be able to draw free body diagrams and also depict free body diagrams when forces are balanced and unbalanced. This is an application of Newton's first law of motion that if you've taken physical science before, you probably have learned about and applied. So let's learn how to draw the most simple free body diagram in existence. Here is a book sitting on a table. So when a book is sitting on a table, there are two forces that are being applied to this book. The first force is the force of gravity. So I'm going to depict the force of gravity by drawing a vector going down towards the center of the earth, and it's going straight down perpendicular to the floor because gravity acts straight down. I'm going to label that vector f of g. From here on out, when we draw free body diagrams must include a box for the object, a vector, and a label for that vector indicating the appropriate force. The second force being applied to this book is a normal force. And after you have defined the forces that you find on the physics classroom page, you will see that the definition of normal force is a force that acts opposite to gravity by a surface. That surface, in this case, is a table, and I'm going to depict that by drawing the vector straight up, and I'm going to make it exactly the same length but the opposite direction of the gravity vector because those forces are balanced. The normal force is going to be counteracted by the gravitational force, and that's what's allowing the book to stay still. This is the most simple free body diagram that you can draw, and it's a great example of a free body diagram with balanced forces. For any correct free body diagram, you don't necessarily really even have to draw the table, because if you label the normal force vector, you can take the table away, and this is a completely legitimate free body diagram as well. So let's really focus in on the definition of balanced force, unbalanced forces, and define Newton's first law of motion. We are finally to the point in physics where we get to talk about Newton's laws. So Newton's first law of motion states that objects in motion will stay in motion. Objects at rest will stay at rest unless an external force is applied to the object. A lot of times Newton's first law is also called the law of inertia. The tendency for an object to stay in motion is inertia. So when we define balanced forces, we can say balanced forces are the sum of all forces acting upon an object, and when I add all of those vectors together, their sum will be zero. There is no external force acting upon the object. Just like you saw with the table and book example, there is a normal force and a gravitational force. They both have the same magnitudes, completely opposite directions, so they add together to have a sum of zero. Those are balanced forces. Unbalanced forces, the sum of the force vectors acting upon the object, will not be zero. In that case, the object will accelerate and move. There will be an external force applied to that object. Take a moment, pause the video, make sure you have these two definitions written down. These definitions also appear on the introduction page on Schoology. So here we are going to draw a free body diagram when we begin to push a book across the table. This is going to be another example of balanced forces because I'm not going to push the book hard enough to get the book to move. So again, I'm going to draw in my normal force. I'm going to draw in my gravitational force going in equal but opposite directions. Let's label those things. But now I'm going to start to apply a force to the book to move it this way. So to do that, I'm going to apply a force, and it's going to be a small force. It's going to be only about that big, and I'm going to label that applied force. Anytime I apply a force to an object sitting on a surface, there will be a resistance force to resist that object to move, and that is what we call friction force. And the friction force will work opposite of the applied force, and it's going to be, when the book has not yet moved, equal and opposite to your applied force. So I'm pushing the book. Let's use a triangle here to represent that I'm pushing the book. I'm pushing the book this way, and the dashed line means I'm pushing it. That's my hand pushing it. There is a force applied, and that is going to be counteracted by the friction force until I apply enough force to the book to get it to move. As soon as I apply enough force to the book to get it to move, I will then have a situation of unbalanced forces. So here is our free body diagram when the book now just begins to move. I will still have a normal force. I will still have a gravitational force. We will always label those vectors. This time, however, I have enough applied force to counteract the frictional force applied by the table. If you want to see a great example of frictional force, take your hand right now and rub it across the table. Feel which direction the table is moving. That feeling of the table moving opposite of your hand moving is a great example of the frictional force that's being applied to that book. Let's label these things. Here's applied force. Here's frictional force. And now this is an unbalanced free body diagram, and that is due to the fact that the applied force is greater than the frictional force, and so the book's overall motion, which we'll depict with a dashed vector, is moving this way. So this is going to be my movement. And it's going to move in the direction that the unbalanced force is moving, which is the applied force. This is an example of Newton's first law of motion, because the object is now in motion because an external force has been applied to the book. So your task now is going to be twofold. First one is you're going to draw some free body diagrams. I am not looking in the first worksheet for you to be able to see the balanced versus unbalanced forces. And then in the second worksheet, you're going to look at some free body diagrams that have balanced versus unbalanced forces and see if you can decide which direction the objects are moving. Hopefully this helped. Have a lovely afternoon.